morning and welcome guys. Welcome to Tales first episode on tutorial series of electronics. I'm your host Shaurya Pandey from the Shaurya Electronics. Today we are going to talk about LEDs. Today I'm going to teach you basically about what are LEDs and what are diodes. Okay, so just a small definition for you to just move on is a diode is an electronic component that allows electricity to flow through in one direction um, and all but stops it from flowing in the opposite way. So let's see what are diodes, because not just imagining this is quite difficult. So let's see how and what are diodes. So here we can see these are diodes. These are the diodes. Okay, so now let's move on to what is diode. Okay, so what are diode is an electronic component that allows electricity to flow through in one direction but stops it from flowing in the opposite way. So it means that if you apply the voltage here, then it will allow it to flow this side where the arrow points, but if you apply the voltage here, it will not let it flow this side. So it's a switch basically. It works like a switch. Okay, unlike other electronic components we have looked at thus far, whose primary role is to influence the voltage or current within the circuit. So like there are many components that limit that influence on the voltage or current and other things, but this diode doesn't influence on voltage or current much, but then also it does something. So the diode is a primary role is to route electricity. So its just role is to just give a direction to electricity. This is extremely useful from preventing electric signals from taking unwanted or unexpected route within the circuit. So if you want a person to go just here and don't if there are two roads like this one and this one, if you want a person to go only with this straight road, then a diode can help you like that. Okay, so all diodes are polarized. This is a very important fact. So every diode is polarized. There are many kinds and every diode is polarized. So this is known as the cathode and this is known as the anode, positive and negative. Okay, so that's the thing. So if you have to apply current, if you have to use diode, then you will apply the voltage here and you will get the output here, and if you apply the voltage here, then you will not able to get the output here. In a schematic, diode looks like a arrow pointing at the wall. So here it's the schematic diagram which you use when you draw circuit diagrams. So it looks like it's an arrow and it's a wall, right? It looks like that. So a good way to think is that a positive voltage can flow in the direction of the arrow. The positive voltage can only flow in the direction this side. So if you apply 5 volts plus, then it will only flow from this side, but if you apply 5 volt plus from this side, it will not able to get this side, and that's the tip. But the wall stops it from flowing back the other way. So I told you, if you apply here, then you will not get the voltage here. So now see how a diode works. Okay, so it's big here. How a diode works. A diode consists of P and N junctions made of P-type silicon and N-type silicon. So as you know, diode is made up of silicon and it's a semiconductor. It have two different types of silicon. One is P-type and one is N-type. So we are not going in further, we are just taking it briefly. Okay, so they are separated by a depletion region. This green line is known as a depletion region, and this is the cathode and this is the anode. Okay, so this is separated by a depletion region, P and okay, it's not positive, it's not negative, they are just P and N. Okay, The depletion region the depletion region acts like an insulator. So these two regions are conductive and it is insulator. It's not conductive. Okay, put simply, the P region is connected to the anode. So this is the anode, means the positive. N region is connected to the cathode. It's the negative. The depletion region sits between the two when the P region is connected to ground. Okay, so if you connect this to anode and this connects to the cathode, then you can see here when the P region is connected, the depletion region actually grows in size instead of shrinking. So this insulator will become more big, so it will not let the current flow. If you will apply negative voltage here at the cathode of this diode, this is cathode point and this is anode point. But if you apply anode on cathode, means you apply negative on the positive side and positive on the negative side, it will, the conductor will become big. This insulator will become more big and it will not allow the current to pass through. Okay, but if you do the vice versa or reciprocal, it will allow, like positive positive and this is the output output. Okay, so it will allow to pass the current. Okay, so this this ensures little to no electricity is able to flow through the diode between the power and the ground. In this configuration, the diode is called reverse blaze based. So if you apply negative on the positive and positive on the negative, this diode will be known as a reverse blaze diode. Okay, so now we know what is a diode, how it's work, and what are reverse blaze diodes. Okay, so now let's move on. When a positive voltage is applied to P region and N region is connected to ground, the depletion region all but disappears and allow the electricity to flow. As I told you, positive to positive and the negative to negative, it will allow the voltage to flow. Okay, so now in the depletion region, in the state of diode is called forward blaze. So if its polarities are connected perfectly or properly, it will be known as forward blaze. Now here we will see how the diode works. Part 2 means more deep inside it. So in order to overcome the depletion region a bit, little of voltage, like here if you apply 5 volts and this will act depletion region which was here. See, this depletion region which is here will act like a quite bit resistor, so it will just take up 0.7 volt from any voltage you have. So it's the thing that the voltage would be taken from 5 volt minus 0.7 volt and you get 3 volts. So that's how the current is allowed to flow. So whenever the current will flow through the diode, it will just there will be a little bit of voltage sacrifice, that is 0.7 volt. Okay, so let's move on to next side. Okay, deciphering diodes. Okay, there isn't too much to know about reading diodes. Typically the name of the diode is printed right on it. So here you can see the name of the diode is 1N5819. So it's a diode. Okay, so if you want a diode, you can just take it. If you just go to a shopkeeper and say I need a 1N589 diode, he will just give you this value diode. So diode doesn't have names, but they have values. Okay, so let's move on, but I just want to go back to this slide once more and just tell you something that like here I told you that it has 0.7 volts. So whenever you the displace this junction, the depletion junction will be there and it will become conductor, then it will reduce 0.7 volts. Okay, so there is one more thing that's known as avalanche threshold, and more things like avalanche voltage, avalanche current, threshold and all. So we would be talking it about a bit later. So let's go to this slide. Special diodes. So there are special diodes. They all the diodes have different work. While diodes by large all do the same thing. So if the diode is larger or smaller, they do the same thing. Okay. So Schottky diodes are very similar to standard signal diode but have a very low forward voltage as little as 0.2 and really fast switching action. ठीक है? So they have a very fast switching action. They are good in application in which diode needs to work very rapidly or amount of voltage loss is required. Okay, so the Zener diode works like a normal diode. However, when a really large voltage is applied to a reverse based Zener diode, the aptly named Zener diode kicks in and allow a fixed amount of electricity to flow the wrong way though the diode through the diode. So this is known as avalanche. Okay, so this is known as avalanche diode. So this makes the diode useful as a crude voltage regulator in a low current application. So this is regulating the voltage. Like if you apply a lot of voltage on a Zener diode, then it will just allow a bit of voltage to go from it. So and that will be regulated. So it will known as voltage regulator a bit. Lastly, the diode that's really shines above the other is LED. So the most common and the most useful diode, or you can say the most used diode, is the LED. So all of you would be familiar with this. So it's the last topic of today. So LED is an abbreviation for light emitting diodes. Okay, all of the electronic components we are going to encounter in this course, the LED gets the most fanfare. This is the superstar of electronic components. You could say it shines brighter than the rest because other diodes doesn't shine, and it works at the same principle of the other diodes, but it doesn't works like a Zener diode. So let's just read this. You could say it shines brighter than the rest. LED is a diode that emits photons when it's forward blazed and there is an electricity flowing through it. The photons are simply light particles and what makes it glow. If you look very carefully inside an LED, you will see a thin wire attached to the center of a small bowl. So if you have seen a filament bulb or Edison type bulb, then you would also know that there is a filament in that bulb. So same as there is a small filament in this, but that doesn't works like a Edison bulb. So we will talk about it in other lectures. That's the topic for another lectures. The wire bridge and the anode cathode. So the filament type thing is known as the wire bridge. Anode and cathode to the semiconductor die located at the bottom of the reflective bowl. When the current flows from anode to cathode, the semiconductor material emits photons. Okay, reflects off the bowl and is further amplified by the plastic material of the cap. So that's all. So if you need these notes or the presentations, you can just visit the website, which is the Electronic Learners. The link will be provided at the comment section, and you can also visit the just like the channel, subscribe the channel, and share this video with your friends so that they can also know about what are electronic components and what is the basic electronics. And please follow us on Facebook, Instagram, Twitter. That's all. Thanks for today.